Hello, everyone. Thank you for joining us for yet another in series of MOVE webinars. As always, we're just going to take a bit of time to wait for all of you to filter through. We have quite a few of you joining us here today, so we'll give you a little bit of time to get through so you don't miss anything. All right. Well, thank you everyone for joining us here today for the Next in the Move series. The focus of this webinar is making transport talk. Thank you so much for PowerTrunk for sponsoring this session and bring together our wonderful lineup of panelists. What we're really looking at for this particular webinar is understanding what the key to a sophisticated smart transport network looks like. We've pulled together a series of panelists who are able to share some shared views on what the industry has been struggling, how transit systems have been struggling to kind of overcome a lot of challenges in the communications, the systems they've used, how they've overcome them, and hopefully you'll be able to draw on their experiences here today to help you with your projects. So without further ado, I think it'd be quite useful for each one of our panelists to introduce themselves, tell them a little bit about who they are and where they work before we move on to a general introduction to the topic and some case studies. Jose, over to you.
Good afternoon, Emma. Thank you very much. My name is Jose Martin, PowerTrunk CEO, and I have been in the land mobile radio business in the US and Canada since 2009, so it's been already a while, and in particular, addressing the requirements of transit agencies among other customers. But today we are going to discuss transit. And so previously, I was working for PowerTrunk's parent company, Teltronic in Spain. I have been traveling the world for many years, and I have to say that I have found always the same challenges, sometimes slightly different depending on the regulatory environment, but typically transit is always very challenging. And what we are going to discuss today is specific of the transit business and the industries working for transit, because you have to continue always operating. You cannot stop anything to try to build something new. So that is one of the things we will discuss today.
Andrew, could you tell us a little bit about yourself?
Sure, thank you, Emma, and welcome everybody. My name is Andrew Schwartz, and I've been in the wireless communications, both commercial and private land mobile industry for 35 plus years. Currently, I'm the Director of Radio Security and UAS Systems at New Jersey Transit, several different roles, but one of which is I have responsibility for our statewide land mobile radio network that serves all of our surface transportation assets, and looking forward to telling you a little bit more about it as we proceed in the presentation.
Awesome. Over to you, Paul.
Thank you. My name is Paul Ajegba. I am the Director of the Michigan Department of Transportation. Prior to my appointment as the Director in January of 2019, I had worked with the department for 28 years. This is my 38th year with the department. So I came up through the ranks in the department as entry-level engineer. I'm a civil engineer by trade, and kind of worked in various areas of our department, design, maintenance, operations, construction, and to point of being a region engineer. Then when Governor Whitmer came in January of 2019, I was appointed. I've been part of MDOT being a leader in the CAV technology arena. I was the project manager for the MCD launch, which is the very first one that we did in Michigan, outdoor lab, where we're testing a lot of CAV vehicles and the technologies and how the system integration. Then we also have the American Center for Mobility here in Michigan. So MDOT, as an organization, we've been very proactive in getting ahead of this technology, understanding that this is the wave of the future, perhaps because we are in Michigan and all the three big three auto industries are here. We recognize we either have to get in or we are going to be forced to get in anyway. So we were being we were very proactive in joining the race. So my topic of discussion today is going to focus mostly on system integrations. How do we get all these old and new technologies to integrate and still have a seamless system moving forward? So I'm really glad to be participating and thank you for inviting me to this.
Thanks so much, Paul. We really look forward to hearing more about that. And last but not least, Sylvain, please introduce yourself to all of our attendees.
Thanks, Emma. My name is Sylvain Privé. I'm working for an engineering company called FNX-INNOV. I'm the responsible for the telecommunications department. Our aim is to integrate systems. So today, company do not want to have only a basic solution, but they want to have integrate end-to-end solutions. And that's what we've been doing for at least 15 years in that company. My background have been always as integrations and communication systems, being part of the communications world with Nortel before, doing some integration of solutions from the 80s, 90s, and then we migrate on to all those new IP technology on the 90s. And what we're trying to do today, try to do something different by integrating solutions, not only providing basic off-the-shelf solutions. We're looking forward to do my part of presentations.
Awesome. So without further ado, Jose, I will pass on to you to kind of set the scene, you know, for kind of challenges that we're seeing. I know you mentioned wherever you went, you're seeing the same challenges across a lot of different systems. Tell us a little bit about, you know, the trends that you've seen and how that plays into what we're going to be talking about here today. So Jose, I think that's over to you.
Yes. Yeah. Can I see the
next slide?
first slide?
Yeah.
Well, otherwise I could discuss the challenges without the slide. So perhaps.
Can you see the slide right now with the overview?
No.
Just to check, the other panelists can see the overview that this. Yeah.
Yes.
Yes.
Okay. So
well, for some reason I can't, but I can. But I have my PowerPoint.
Okay,
open.
brilliant. We're just on the overview slide. I think we're able to see it between the other panelists and ourselves.
Okay, so I'm going to use my PowerPoint.
Yeah,
no,
perfect.
That's not any problem. Well, as I said, there are many challenges because the technology evolves, and there are new solutions, and there are new requirements because there are new solutions, and that sometimes leads to difficult decisions to be made. One of them is the integration of different legacy radio technologies. In the US and Canada and in many other countries, there are many different radio technologies, and you have to continue using them in a typical transit project when you are delivering a new solution based on a new technology. The legacy system must continue operating. And that is as though you are building hybrids and then scaffolding is the essence. And sometimes the scaffolding is more complex than the system itself. So that is the first thing. The increased needs normally comes from the number of passengers, which is always increasing, and also the passengers become more demanding over time. Also, there is an important consideration about the interoperability with public safety networks. Over time, unfortunately, transit systems have become the target for many different types of attacks or threats. So it is of the essence that whatever kind of a new system you want to implement, you will need interoperability with the public safety networks. That depends on the specific requirements in each country, and that is sometimes complicated. Because you have to meet different standards requirements at system level, at the subscriber level, or both. So there is something else which previously, I mean, many years ago, it was simply assumed that speech quality was going to be poor. But nowadays, nobody will accept any new solution not providing at least sufficient speech quality to recognize the person you are talking to. And that may sound very simple because everybody's using cell phones. But in the land mobile radio systems, we are requested to provide the same quality. Spectrum efficiency is a consideration not visible to the user. Of course, passengers are not aware of those challenges, but governments and the authorities are always concerned about how to efficiently use the spectrum, because the spectrum is a scarce resource, and there are new technologies capable of providing sufficient communications capacity with decreasing spectrum per channel. And also, we have data applications. Even though land mobile radio is clearly a narrowband technology, there is an increasing demand of data-centric applications. It is not comparable to what can we do with broadband technologies, and that is a different chapter. But the land mobile radio solutions are requested to provide reasonable data communications capabilities. And lastly, this scalability and sustainability. With whatever you build must be scalable because it is assumed that the number of passengers and the level of demand from the passengers is going to increase over time. And even your geographical area is expected to expand. You know, and that metropolitan areas are always growing, or perhaps the density of the service spots is going to increase. And that leads to expanding the capacity of the systems and the data payload and also, of course, RF coverage. So you've seen that there are quite a few challenges to address. Next slide, please.
Yeah, we're now looking at main communication requirements. Yeah.
To click on the next slide. Okay.
Main communication requirements.
So the main communication requirements. Well, of course, the basic thing is communication between drivers and control centers, depots and passengers. There are many different situations. During normal operation, you will need those voice communications. But it is of the essence also, and it has become a mandatory requirement to have automatic vehicle location available, so that from the control center, you know always where all the vehicles are located in near real time. And because we need to be very careful about that. And when we say real time, sometimes it is not instantaneous, but you have to refresh the position of all vehicles in a reasonable period of time, which has been assumed in almost all cases to be 30 seconds. And that is a challenge itself when you are using land mobile radio. That includes the remote monitoring from onboard systems. For example, for diagnosis, not only diagnosis of the radio equipment, but also of the vehicle itself, because those onboard systems are designed to monitor certain parameters of the vehicle and certain alarms so that the proper decisions can be made at the control center. And that also includes emergency communications. What if something unexpected happens, and at that time, the communication system is busy, so there are no available resources, how to handle that situation. So, of course, in all cases, we need to preemptive emergency calls so that we can release the necessary resources so that the emergency communications can be set up immediately. And also the communication with maintenance crews, not drivers, not vehicles, but boots in the ground, taking care of a lot of activities in connection with transit operation. And that means a lot of people not even close to the bus routes or to the light rail routes must be within the coverage area so that they are reachable. And the last point, railway signaling, I would say it's an entirely different requirement because normally land mobile radio has been used for maintenance, for operation, but not typically or not often for signaling. Because railway signaling is technology itself, which is subject to evolution. And so railway signaling has or involves certain specific requirements, for example, in terms of latency. So different land mobile radio technologies have different latencies and different availability requirements. And there is a strong debate in the industry sometimes and a lot of confusion to make a distinction between safety and availability. So I have participated in many debates about that. So I have to say that land mobile radio should not be part of the safety system. However, availability is of the essence because a system can be very safe, for example, a light rail, but if it stops very often, all the trains stop very often because the system is not available, doesn't matter how safe the passengers would be, but they are going to be upset anyway. So let's go to the benefits.
Moving on to the benefits, yeah.
Yeah, so what benefits can we expect from the state-of-the-art land mobile radio technologies? In the first place, simultaneous voice data and location services in the same network. This is very interesting because until recently, and in particular in North America, it was assumed that this was not possible because data communications are assumed to be supported by other technologies, in particular broadband. But the state-of-the-art LMR technologies allow voice and data communications in the same network. And as I said previously, we can make effective use of the frequency spectrum, which is becoming more and more a requirement imposed by the authorities. A few years ago, it was a recommendation, but now it's becoming a mandatory requirement. Then applications such as GPS for automatic vehicle location, SCADA for remote monitoring of certain devices, for example, for telemetry. Also support large-scale capacity to meet the increasing user needs I mentioned previously. So we need to be capable of having the system grow. And interoperability between all users at RF level. Well, this is very easy to say, but not always as simple to implement. Because there are different frequency bands and different requirements. The legacy systems sometimes operate in different frequency bands. And then normally we address those requirements through gateways, when there is no chance to use the same spectrum. Some additional features such as text messaging, which are typical of cell phones, so that is also normal in LMR technologies. The calling ID, so you can see who is calling you, and individual and group, and all the typical public safety related features. Then, there is an important thing about LMR technologies compared with broadband, which is the number of towers you need to implement a given system. That has to do with the modulations used. In LMR, normally we are using phase modulations. However, broadband is based on amplitude modulations. With LMR, the performance, the system performance is the same across the entire RF coverage area till the edge of the coverage area. Some other technologies provide more data throughput, but the data throughput drops as you are getting away from the towers. With LMR, you don't need too many radio sites. And that is an important consideration in terms of cost. This is of the essence when, from a budgetary standpoint. And as previously mentioned, the integration with the first responders networks. And I have to say that the transit agencies are first or are deemed first responders themselves. So it is of the essence that they can communicate with other first responders in the event of emergencies. Speech quality, LMR has many advantages, but anyway, it must communicate with other systems based on broadband. For example, systems supporting video, which is not typically vital service. But anyway, there must be the possibility to communicate with other networks. And what we are promoting, we are doing actually and implementing in the real world lately is so-called mission critical push-to-talk. So that gateways allow LMR system to interface, for example, 4G or FirstNet or other private LTE networks, or any other broadband technology. So that is becoming not mandatory. There is no legal requirement, but practically all customers are demanding those solutions. So lastly, as a matter of preliminary conclusion, because this is just the beginning of this discussion, that mass transit, buses, trams, subways, railways, and others, and including airports, need efficient communication systems. Because their operations are becoming more and more complex, and the user's demands are more and more complex.
What do you mean?
So efficient communication systems is a requirement. And then I would like to hear from the other panelists, how did they address and overcome the challenges, or how did they do it to make it happen?
Brilliant. Thank you so much. I can see from everyone in attendance that we've got a few questions coming in. Do not worry. We will be most definitely referring to these towards the end of the panel. We've allocated a good amount of time to be able to feed through your questions. So keep them coming and we will get to them. But for now, what we're going to do is just go through a few case studies that kind of demonstrate what Jose has kind of spoken us through already. And we're going to be starting with Michigan, with Paul. I'm from Michigan DOT. And Paul, take it away. Tell us about your experiences and how you guys have overcome them.
Thank you, Emma. Again, thank you to the rest of the panelists. I'm going to try to be as brief as I can so we'll have enough time to discuss some of the questions that are coming in. If you could go to the next slide, please. Part of, as I mentioned earlier, Michigan DOT, we're one of the leading DOTs in the state that got into the CAV technology uh, uh, design and implementation. And part of being first means there's a lot of challenges. You become the guinea pig, you're a leader, but you are deploying a lot of hardwares and technologies out there that, with the way this whole uh, industry is changing so fast, in 6 months, something you put in could be obsolete, or the new technologies. And there's a lot of players in the market now where they all create their own standards and specification issue where what you've put in does not integrate with the new system. So those are some of the challenges we've had to deal with, integrating existing system with new systems. As I mentioned, it's tough. Planning the integration of future and undefined systems where people come to us, as I said, Michigan being a leader, well, we'd like to try this on your system. How do you feel? First, I will give our previous legislatures a lot of credit. They passed a lot of laws that encourage Michigan to be a test bed for a lot of these technologies. So we had a lot of design companies come in, want to work with the big three to try these hardwares on our system. So we were open-minded to that. As some of you know, we're having issues right now with 5G and DSRC. Which technology should we use? For us at MDAP, we've been staying neutral on it, but these are some of the challenges we are working to try to overcome as we go along in this new area. Gauging technology advancement, it's a real issue. Real world testing of technologies through project and pilots. As I mentioned, freeways and roadways, we've always tried to allow new startup companies or work with the big threes to try real life situation on our freeways, so we can gauge whether this stuff works or not. And that's been part of the big challenge. What we've been able to do to close this challenge gap is by getting involved in a lot of the industry committees and boards to make sure that we are representing the DOT side of the equation and try to get all the players to talk to each other and work together to make sure that we are having a seamless standard and specifications during the development phase. Next slide, please. So as I mentioned, challenges in CAV regulation, FCC ruling for spectrum allocation, 5G DSRC, there's a discussion going on now about, okay, which one are we going to be using moving forward? Us as a DOT, we've tried to stay neutral, but I will tell you, there's a company right now that's developing a system that integrates both DSRC and 5G. And that's what we'd like to see, because lack of specifications available for technology, it does not help us to be able to know which of these technologies should we allow in our system or in our right-of-way or not. And then cybersecurity is a big issue. Legality, I spoke at one of our major universities here in Michigan, maybe sometime last year. I was invited to speak to some of the law students about what are the legalities of this new technology moving forward. The insurance part of it, when you have an accident, where you have an automated vehicle and a non-automated vehicle, how do you decide all this moves? So there's going to be a lot of legislation, a lot of laws that have to come behind what we're developing to make sure that there's, again, not just the technology integration piece, the society piece, insurance, the legality, all that has to all play together. And I think moving forward, these are situations that we're all going to have and confront. ITS infrastructure deployment, it's never designed with security in mind. So how do we go to the next level? And while we're trying to get to the next level, make sure that the new technology is still compatible with the old technology. So working with industry and legal environments to define the framework is being part of our task. Next slide, please. And then in the interoperability arena, interoperability of various manufacturers developing similar hardware or software. That's what we've been playing that role to make sure that when this discussion is going on, we are in the room to try and steer the manufacturers and the designers to talk to each other and make sure that the DOTs are included in this conversation, because we don't want to put something out there that's not compatible with our system either. The hardware, software, and infrastructure elements for operation of a complete system is really the key moving forward. There are 5 factors of interoperability. That's the architecture, the standard certification testing, which we have a lot of that here in Michigan with MCity and with the American Center for Mobility, and also the human factors of this. How do we get the non-believers to buy into this new technology as a way of the future? So that's my presentation. I'm going to pass it over to Andy Schwartz from the New Jersey Transit, and hopefully I will be able to answer a lot of your questions. Thank you.
And thank you again. Keep sending your questions in. We will get to them at the end of the presentation. So hang in there. On to you, Andy.
There we go.
Yeah, you're on mute.
Thank you, Paul and Emma. Very nice presentations. My name is Andy Schwartz, New Jersey Transit. You can see a map of the United States for those who are not familiar where New Jersey is. We're that little state right across the river from New York City. New Jersey Transit is the state of New Jersey's provider of public transit services.
Nice add-in. Should have had that, Paul Christopher.
With 3.3 billion annual passenger miles, that makes New Jersey Transit the 3rd largest transit agency in the United States and the largest statewide transportation agency. And you can see from some of the pictures there, we run buses, commuter rail, light rail. We also have our access link for paratransit services and a van pool operation. So many different modes, and that's just a little background about New Jersey Transit. Next slide, please. Thank you. There we go. Whoop, back up one. There we go. Perfect. So one of the biggest challenges that we faced back in 2013, we realized that looking forward into the future, we found ourselves with obsolete radio communications technology. We knew we had to do something. In fact, the equipment that we had used had been obsolete for some period of time, and only for the skills of our technicians were we able to keep the system running. The other thing we faced that helped, was a catalyst for a decision to move forward with something new, was the New York metro area hosted the Super Bowl back in 2014. And it's just a gigantic influx of people into an area that supports the Super Bowl. So we were expecting people from all around the world coming into the New York metro area, needing help basically to get around using our system. So that was a driver. We really need to improve our communications capabilities. And finally, we were faced with some regulatory issues.
Watching Paul Christopher be
at
part of a webinar worldwide.
New Jersey Transit
coming out of the UK.
Change our spectrum. from where we were operating to a different portion of the spectrum in the US, and that was to mitigate some problems we were having with interference to other public safety agencies.
I know.
Sorry, guys, there's some interruption. Oh, there it is.
Okay, there we go. We had some background noise. So taking all of these inputs, we basically made a decision, we have to do something, and we decided that it was time to go out to the marketplace and put out a tender for a new advanced communication system. Something that would address the current needs, address the regulatory issue of having a new spectrum, help us manage the advanced requirements that the Super Bowl is bringing into town, and again, help us carry us into the future. The last radio system we used for almost 35 years. We wanted something that had some staying power that could support both voice and data and take us into the future. So you can see on the right-hand side of the screen, we were presented with a number of different paths to follow. And in the end, we ended up going down the path of Tetra technology to meet our mission critical communications needs. That's how we look at this. We look at ourselves, at least from the technology standpoint, as a public safety agency. So it was extremely important that whatever technology we ended up with, it supported mission critical reliability. It had to be resilient. It had to be able to withstand anything that New Jersey Transit might face, including things like hurricanes, floods. We have those. So next slide, please. So I was asked to speak about some of our biggest challenges. I think I just really talked about them. We had a very compressed schedule. So in terms of the FTC mandate, we had to have our new system in by the end of 2013. We awarded our contract in early 2013. So we really had to go very quickly in terms of getting something on the air that would meet the rebanding requirements, as well as give us the communications capabilities that we needed in the short term. And primarily that was for Super Bowl. In terms of our procurement, it was a very hostile competitive environment, and anybody who gone out and procured land mobile radio networks knows what I'm speaking of. It's there were very few avenues in terms of vendors that supply this equipment, and of course it's highly competitive. So that was we faced a lot of different pressures from various people who wanted our business. The other thing, as Jose spoke to earlier, was interoperability. In the area of New Jersey, there's multiple technologies that are used. There's P25, there's conventional, there's DNR, there's FNX-INNOV, there's every acronym for different types of land mobile radio systems available out there. So
your sound is Andrew breaking up a tiny bit. It should be all right now, but just a heads up.
Yes, that was my own stopwatch telling me to hurry up. So and then the final thing was the challenge was integration. So we had a fairly complex CAD AVL system, an old one as well as a new one, and we needed to figure out how we wanted to get a system that would allow us to integrate with our CAD AVL systems that are used to communicate with our fixed route buses. The system that we ended up with supports both CAD AVL dispatching as well as standard trunking. So two different types of operations hosted by the same system. The other important challenge was how are we going to serve our data needs? And an example of that was being able to transport some train control / alarm systems from our light rail vehicles. Next, please. All right, so how do we deal with the compressed schedule? So rather than, like an engineer, just put sites on the map that would be perfect for your network, that's not really reality. So what we had to do is basically back into a design using available sites. That allowed us to very quickly get sites up on the air. And these sites could have been existing New Jersey Transit sites as well as partner agency sites, both public and private. The other thing we did is we first deployed the trunking portion of the network to get us to meet the FCC requirements and deal with Super Bowl, and we held off on the CAD-AVL portion of the project until after that was accomplished. The second thing, which is technology selection, as I mentioned, it was a very competitive environment. Rather than selecting a technology or selecting a vendor, we came up with some very specific business requirements, and that drove really the selection of technology. We had a technology agnostic specification. We didn't write it, to favor any specific technology. We had a very clear list of business requirements, and that drove the technology selection, which kind of got us through the hostile competitive environment situation. The other thing on the spectrum side, because we ended up with Tetra, and by the way, it was the first commercial Tetra system in the United States to be deployed, we had to work with the FCC, which is the federal regulatory body in the US, to come up with new spectrum, because the spectrum that New Jersey Transit had operated in did not allow Tetra as it was. So we were able to successfully negotiate new spectrum that allowed us to deploy the Tetra technology. And then finally, rather than developing anything special from an integration standpoint, we just went with a standard CAD product and leveraged the manufacturers. When I say manufacturer, I'm speaking about the land mobile manufacturer, their standard API interfaces to create an integration between CAD and the radio network. The other thing we did is split on the data side. We initially used cell data as the vehicle for the CAD-AVL integration, later moving to Tetra data. And finally, we used Tetra data, Tetra status messages for light rail vehicle alarming. That was one of the things that we took advantage of with a Tetra network from a data perspective. Okay, next, please. So in the end, as I said earlier, we awarded a contract in 2013. These are some of the things that we took advantage of: the integrated voice and data. We went with a standards-based technology versus proprietary. There's a worldwide ecosystem for Tetra, which opens up many avenues from a procurement standpoint, as well as applications for New Jersey Transit. Given that we operate in a high noise environment, Tetra has excellent voice quality and performance under high ambient noise environments. We didn't want anybody to have to worry about what channel they're on or what zone as they're moving throughout the system. It's a highly mobile network. So with the technology that we ended up with, all of that is automated. Again, speaking to what Jose said earlier about security, our system supports authentication and encryption. We are not operating encrypted. We do use authentication. We have a third-party CAD system that interfaces into the Tetra network that does provide GPS information, not only to the CAD system, but to other applications. And we take advantage of the short data service and packet data that Tetra provides. Next. And this is my last slide. On the right-hand side of the screen, you can see that's internal users within New Jersey Transit, all the various different organizations that benefit from our mission-critical land mobile radio network. Traditionally, it had just been the buses and the light rail vehicles, but once people saw the benefits that a mission-critical, widely available Tetra network provided, a whole bunch of other organizations jumped on board and now use the system as part of their daily lives. On the right-hand side or left-hand side of the screen are other users of our network. It's not strictly limited to New Jersey Transit, which is a great thing. So we leverage other partners' infrastructure, as well as let other transportation partners that serve areas within New Jersey that are not served by New Jersey Transit. We let them use our public safety mission critical network for their operations. It benefits everybody. And that's my presentation. Hopefully there'll be some questions later on.
Awesome.
Thank you very much.
we're definitely gathering up some questions. So we've got 15 minutes left, and that should give us perfect amount of time for our final case study from Sylvain, as well as to answer all the questions that you guys have very kindly been feeding through. So over to you, Sylvain.
Thank you. As I said initially, we are an integration company, and our day-to-day business is to make solutions from various components. We've been the lucky one to have assigned the contract of the STM to upgrade their networks from the old technology eDAX towards a new technology. So just basically, who is the STM? Just to put you in the context, STM is the one of the largest transit company in Canada, one of the largest, and is existing for over 150 years, so quite a long time ago. It's running 4 metro lines, running over 71 kilometers of underground tunnel, and 68 metro stations covering the islands of Montreal, and also offering transit to the other geographic area like the south, the north, east, and west. Also offering the bus transportations overground to the full islands, plus the transit area. It provided at the moment up to 80% and more 80% of the all public transit services in the region of Montreal. You can see over 10,000 employees. One of the typical information about ASTM is they own and manage most and all of their solutions, which mean that they have their own control centers and managed by their own staff, which mean that they have their existing solutions and they want to continue to evolve those solutions by adding new pieces to those solutions. This is what we're going to see in the next slide. Next slide, please. Roughly, what is the project all about? The project is about a redundant core network, tetra core networks, which include all the pieces that we know. 112 underground base stations to offer RF coverage to the full area of underground, and 4 underground base stations, which offer 100% coverage for the STM requirements. They also have the recording systems, centralized systems, and what I want to talk to you about today is more about some of the new data applications, data interface that we need to build in order to make that systems happen. STM also purchased a full lab, which is quite interesting. It's a full lab that it can do all the testing prior to go on site and deploy part of the networks. So they have a lab for training, they have a lab for engineering, and they have a lab for services requirements as well. Of course, numbers of different radios, different types, portable, mobile, but especially radio on board of a train, which we're going to talk in a minute, BRT. Next slide, please. So this slide is quite interesting. As I mentioned, customers do not want to have a separate solution sitting beside each other. They want to have an end-to-end solutions, including their old operation and old systems migrating together. STM already have a huge control centers to manage the operations and using the old eDAX systems. So one of the challenges we have was to make sure that our new Tetra networks integrate with those existing functionalities. As you can understand, a system like the STM networks is covering a large area, and communication need to be sectorized in order to provide the perfect services. So this was one of the challenges, how we're going to do this sectorizations in all of the zone. So to better understand what sectorized is, the train will move from one place to another and will cross many zones during its transport. So not all the people need to be on the same conversation at all times, which is going to require a lot of RF frequency and channel to cover the communication. So what we did is we separated all the zone by sectors, and we're trying to assign, we monitor the train, monitor the traffic, and we try to assign dynamically all the traffic to the right zone according to the time and the movement. So to do that, then we have developed an interface which interface with our Tetra system, the Sikoko and the Tetra core networks, using the own protocol of PowerTrunks N2A. And on the other side, we have to interface with many different systems and many different applications. This design allowed now to manage and monitor the networks live and adjust on a timely manner, seamless to the user, seamless to the passenger, and seamless to the operations, all the communications when the train is moving. The other function that we have to develop integration for is they have some announcements to the passenger, the PA systems. So the PA systems was using the radio channels to communicate the information, either pre-recorded or announcement that we need to do for emergency. But the system needs a new path that will allow the operator to trigger those recording messages to the train driver and to the train users, and to be able to use the right channel and the right path on the right sectors for the right messages. So the system has been made in order to understand where the train goes and play the right messages at the right time. So the existing systems also have a numbers of elements that we need to manage. All of those elements that we need to manage, of course, need a centralized operation and management systems. Every active system that made the full networks will be monitored under the new AMS. We understand that each of the systems, like the Tetra system, have its own AMS, but that was not sufficient to have a common and central management of the full networks. So we have made interconnections and interface to each of the systems, connecting SNMP traps, managing the entry point of each of the active systems, and centralize them towards our new systems. We also developed a different view to monitor the networks as per the customer recommendations. What's very important also is, as you can see on the bottom right of the screen, the STM already had their console to manage the networks. So the operator have some use to the old console, and they want to keep always about the same structure to manage those networks. So we have also developed and enhanced our console to adapt to the new requirements of the STMs and allow those operators almost a seamless transit operations to their new systems. Interoperability, that's been mentioned many times during this presentation. It's a key of all the transit networks. We cannot transit such a networks over the night. It takes time, and also you need stabilities between the two networks. So most of the solution that exists out there, it's a basic analog gateway between two solutions. That was not sufficient because of the numbers of talk group that we have to manage simultaneously into this project. So we have decided to develop an interface at the IP level or the core level between the Tetra systems and the EDAX systems to offer more than few frequency and radio to transfer the call. So this network is going to be operational from start to the end of the transitions, which may take several days, several weeks, or months, doesn't matter. To be able to do a smooth transitions, of course, you also need to equip the train with specific equipment. Each of the trains today are equipped with eDAX radios and numbers of peripherals like antenna, like speaker for the users, and the cable already passed into the train. It's impossible to remake all of those accessories, which I call, and be able to transfer them overnight to the new systems. So one of the requirements of the SCM was to create a box that will allow automatic or manual transfer between the eDAX systems and the Tetra systems. So this box has been created with using basic mobile radio, but having its own controllers, and from different triggers, it can switch from one network to the others in half a second. So which allowed the train, if ever it goes on a migrations toward the new systems and have a problem, they can go back and revert to the old systems just by sending a triggers either by frequency tones or SMS or a manual command. Last but not the least, all of those networks that we have developed need to be very reliable for a 24/7 operations. All configuration has been tested in a very different geographic redundant situations, and every pieces of equipment we have deployed need to be able to work in a degraded mode. As you know, for transit networks, you cannot leave a train in the middle of the track if the radio communications stop. So you need to be able to bring those trains to the garage and in a safe area with the passengers. So everything has been tested twice. We're still currently deploying these networks, but the added value or the conclusion I want to make is in the new application from an end-to-end user point of view, you don't want to only buy a pieces of new solution. You want to be able to have an end-to-end solutions. And to do that, don't stop yourself because the system cannot do it. Integration and development can help you to achieve your objective. So here is my presentation. Thank you.
Brilliant, thank you. So we're going to move on to questions now. We might run over a couple of minutes, but I just want to make sure that you all get the answers that you want. A few of you have actually asked for the email addresses of our panels here today, so we'll make sure you're able to get in touch with them after this with any follow-up questions. That's no problem at all. But the first question actually is for you, Jose, if you can hear this. We have a Fernando saying, I understand when you mean having near real-time location of vehicles. Have you actually looked into improving that real-time location inside certain places, i.e. transit garages, maintenance areas, transit yards, transit stations, using other technologies like UWB? Fernando says they're currently doing this with Minneapolis Bus Transit and other transit authorities, and wanted to hear what your thoughts were on that.
Well, as far as I am concerned, because, you know, I am the supplier, not the operator. But as far as I am aware of, I believe that 30 seconds is deemed sufficient by transit agencies and also the CAT AVL suppliers. You know, CAT AVL is a complex application governing a fleet of vehicles, making possible to issue automatic instructions and preparation of reports in real time to support the decision making of the transit agencies. So CAT AVL suppliers are telling us that 30 seconds is sufficient. And it is not so simple to accomplish that when you have limited resources. And so that is why we have developed overlays on top of the Tetra technology to boost the system's ability to gather information from the vehicles. Well, of course, we can do it faster, and the only thing we need is additional bandwidth. So there is nothing to prevent us from refreshing the position of vehicles every second or 2 seconds or 10 seconds. but there is a compromise between the bandwidth you want to use and what is the real need. You know, everything in life is a matter of negotiation. So with unlimited resources, we can do it in 1 second or less. But our customers are not asking us to do that. So regarding depots, well, that sometimes is an issue with CBTC implementations. You know, driverless trains, and when the depots are fully automated, there are a lot of vehicles in the same place. So for that kind of cases, we are using solutions based on Wi-Fi because Tetra is not a suitable technology for a very short latency period. And in the event there are many vehicles automated in the same depot. So actually, Wi-Fi is a complement to our solutions in some cases.
Great. And another question, actually, we had quite a few on these, is asking about the optimization, and perhaps this is for the whole panel as well, but maybe, Jose, you can start. The optimization of CO2 emissions. Do we focus on this as well as safety? Quite a few people have asked questions around the management of CO2 emissions.
Well, I think it's better other panelists address CO2 because we are not operating vehicles.
You know, this is Andy Schwartz, New Jersey Transit. I'm not in the organization that manages the bus fleet, but I can say that you know, we do have a fairly sophisticated onboard. We'll call it a ITS solution. That's part of the, one of the things that it does is the CAT AVL on the radio side, but it also has a, you know, a maintenance system and is tied into the various computer buses that carry engine information and other sorts of engine transmission, you know, various, you know, sources of data from the bus. And I don't believe it actually optimizes it, but it does provide all the information for our maintenance people to understand, you know, the health of the buses, which may impact CO2 emissions. I know a lot of our buses are clean natural gas, so there's really no CO2 emissions that I'm aware of, but we do have some pretty advanced onboard systems that do monitor bus engine and transmission parameters that probably can help maintenance people manage that sort of thing.
Great. I've got another question here from Neil Seamus, and he says, have you any indication from vehicle manufacturers that they would, and transport operators, that they would be willing to share some key elements of their tech so a city or an entity doesn't have to develop 15+ interfaces to collect, process, and apply data? What are your thoughts on this panel?
Well, my thoughts are, I think the bus manufacturers make all the data available, you know, in one or two places on their vehicle. Again, I'll just speak to what I know about. Again, I'm not in the organization that manages the fleet, but there are interfaces that can gather all kinds of information from a single source on board. What I've seen, though, is because you know, within many organizations, there's a lot of operational silos. So it's really important that within, you know, a transit agency or, you know, whatever the type of organization we're speaking of, that there's good communication, you know, across the various silos, whether it's, you know, between an IT organization and an operations side, to make sure that all of the requirements have been identified well in advance when it comes to procuring a vehicle or speccing out a vehicle, so you don't end up with multiple redundant systems on board, such as, you know, 5 GPS antennas and 3 Wi-Fi units and 2 routers, and that can happen. And it's not so much, I think, on the vehicle manufacturer as it is, you know, within the transit agency, making sure that all of the stakeholders are speaking to each other, and that you have an integrated specification that minimizes the onboard equipment and maximizes the availability of data for all of those key stakeholders that are looking for that information.
Great. Well, just to balance some of the questions that we had ahead of this versus some of the questions we've had now, I just wanted to move without running much too late over schedule. We've got another 5 minutes. So which one of these, Jose, would you like to focus in terms of the questions that we've got that were pre-submitted? We've got...
You know the slide?
Yeah, on the debates, we had collected some of the questions ahead of time that some of the audience wanted to see. We have maybe time for 2 of these to hear your thoughts. Did you have a preference over which one we covered?
Well, perhaps, I'm going to skip the first because
we've covered a lot.
I have to recommend my technology.
Yeah.
So I think it is very interesting, the integration between narrowband and broadband technologies.
Okay.
There's a lot of confusion in the market, in my view. What can you do? What can you expect from narrowband and broadband? So I believe that clearly narrowband is more efficient in terms of RF coverage. So you need fewer towers to get the same coverage. With broadband, in the event you want to make video service available across the entire coverage area, you will need many more towers, and that is something many users cannot simply afford. So narrowband is, in addition, mission critical capable by definition. For example, Tetra and other LMR technologies have been designed precisely to be mission critical capable, and that has to do with functionality and availability. So narrowband is the system you can rely on when something else goes down. And that happened many times. I remember, for example, Hurricane Sandy hitting New Jersey and New York when all cell phone systems went down for a couple of weeks, I think it was. The LMR systems were precisely the only ones to stand in those situations, and that allowed to coordinate the response from all the agencies involved. And that can happen again at any time. So no mission critical solution nowadays can be supported by broadband. However, broadband is very interesting from another perspective. Video is very useful as long as you don't use it to support vital activities, and because those networks can go down at any time. So to give you an idea, well, there is another panelist here very much aware of what I am going to say. We are requested to guarantee that the Tetra network in New Jersey is available 5 minutes, which means 99.999% of the time. So if you get a calculator and translate that to minutes, that means that we are only allowed for the network to go down 14 minutes in a year. So that is the requirement. And 14 minutes is a very short time in 1 year. And this is exactly the requirement for all the networks supporting first responders. So there is a combination clearly between narrowband and broadband. And so both are complementary, not exclusive. And clearly, in my view, of course, because there are other opinions, but in my view, broadband will never replace narrowband. So land mobile radio is healthy and will continue going forward.
Awesome. Well, I think everyone, that is all the time we have today. Thank you everyone for staying on from start to finish. Looks like we still have a full house, which is brilliant. What we are going to do is follow up with a recording and the slides from this presentation, because from the feedback we've got so far, it seems that a lot of the information on these slides is something that you would like to revisit. We will also provide you with the direct contact details of our panelists should you want to reach out for a follow-up conversation and individual questions that you might have based on each one of the case studies we saw and each one of the explanations of the technology. I'm so sorry we couldn't have gone through all of your questions today. Unfortunately, time ran away with us because of all the brilliant information we saw. But thank you so much again for joining us for yet another MOVE webinar. We hope you have a lovely day for wherever in the world you might be joining us, and we hope to see you all soon. Thank you so much to our panelists as well. Have a lovely evening, afternoon, or morning, depending on where you are. Speak to you soon.
Thank you.
Thank you.